Welcome to the Solana cryptocurrency quest. With this quest, you'll get up to speed with the most rapidly rising blockchain in the market. Okay. In this quest, we will be developing our own cryptocurrency on the Solana blockchain or our own SPL token in the Solana lingo. Okay, so SPL token is equivalent to ERC20. This essentially means that once you're done with the quest, you'll be able to make your own cryptocurrency using Solana programs and use that to do whatever you can think of, including using it as a fan token, social governance, utility, or a coin. Okay. There are a few things that we need to get up and running before we move forward. Okay, I have all of this running, but in case, hey Varun, regarding beginner sessions, actually today we don't have anyone who is uh, Krati, do you want to do the beginner sessions? But we don't have that many people who are beginners today. Um,
Hey, so yeah, we can plan a beginner session next time because
yeah,
today I am also interested to do this, what you are doing, right? I'm curious for this.
yeah. So then, Varun, why don't you just stay in the main room and just try to follow along. Like, even if you are a beginner, I think the quest is fairly like from starting from point zero. So just try to do it along with us. Maybe we will set up a beginner session next week.
Yeah,
Uh,
I think Varun was there in the beginner session last week. So I think Varun has the basic Rust knowledge, right,
okay.
Varun?
Yeah, I was there in the last week, but I thought that these two sessions will be different. But anyways, I'll attend this.
Yeah, now the only thing difference between that and this is you need to install Solana, and that's all. Everything else is pretty much like we can
Yeah,
start from there.
yeah, you can start from there. And also, like, we generally have beginner sessions like taken by Prakash, and Krati was able to take one for us last time as well. So we will try to do like whenever we can, whenever people are available to do the beginner sessions. And if not, if you have attended one or two also, I think should be good to go. So let's do.
Okay. Thank you.
Okay, so I have most of these things set up, but if you guys want to take your time and set this up, you can do it. I'm probably going to start from here. Set up my terminal. Oh, my screen sharing is paused. Share my desktop. Okay, so I'm going to do anchor init. So now that we have moved to a lot of advanced sessions, and we will be moving to more and more advanced ones in the next couple of weeks, I suggest everyone to just do it, along with us as we are doing it, because this is what will kind of help you get the hands-on part of it, right? Okay. CD mining. Okay. Um, First, we check whether we can see the programs. Yeah. We can see the programs, app migrations. The node is also configured. We have anchor.toml. Let's just open this up in VS Code. Oh, so, this is the most basic example. What's happening is that, okay, yeah, this we already have seen. So if we go inside programs, source, this is where we'll find the lib.rs. So let's see. Oops. Yeah. So we have this. The basic program always comes with like the name of the dApp and a small function called initialize, which has an empty initialize context. Okay, that's what you're saying. Let's try to compile this so we know that everything is fine. Anchor build. This will take a while because it's gonna build all the Rust dependencies and stuff. So so trigger a build function. It creates a new folder called target where the compiled file binary will be there. And then we can use the binary to actually deploy and stuff. So, all right, so we can also see that there is a default tests folder which has the test for this particular lib.rs. It sets the anchor provider from the environment, and it takes the program in from the workspace. So we say the workspace my money dApp. So one of the things is that the program that we have, even if it is called like small case my money dApp, in the test it uses capital M from the workspace, because this is a similar behavior that we have seen in the front end as well. So just want to highlight this. And then we are just checking if the initialize function is working or not. So we take the program and then we use the RPC and call the initialize function. So this is a generic test. Right now it is building, so let it just build. Meanwhile, we will go to the next step. All right, so we have head over to programs my money dApp cargo.toml and add the following line. So we are adding the anchor SPL. Before this, let's take a look at anchor SPL if there is any theory. Okay, this is just API documentation. Maybe not very well written. SPL Solana. Okay, Solana program library docs. Here SPL token is there. Okay, it's gonna take a while because Rust compilation. A Solana program library is a collection of on-chain programs targeting the C-level parallel runtime. So we know that I think we did this very early in the game, but how we have EVM, which is the Ethereum virtual machine, it converts the code into bytecode. It converts Solidity smart contracts into bytecode and then compiles that. So similarly for Solana, the compiler standard is called C level. So this is the C level parallel runtime compiler. And all the programs that we actually write on Solana get compiled on this. So the Solana program library is a collection of on-chain programs targeting this particular compiler. These programs are tested against Solana's implementation of C level, Solana runtime, and deployed on its mainnet. As others implement C level, we will graciously accept patches to ensure the programs here are portable. All right. So this is the parallel processing infrastructure that is C level. It's a so proof of history is what Solana uses, clock before consensus, Byzantine fault tolerance, a variation of that, Tower BFT. But yeah, I don't think we have to go into this as of now. But if anybody is interested, I'm sharing the link here. So this is a good read. I have read this before very long back, but it's a good read about the Solana ecosystem and how programs are running, how transactions run, and what actually happens at the underlying CPU level. How are they registered, clustered together, 32-bit, how is the RAM and stuff. So you get to know everything. CUDA became popular after AI, and this particular architecture is like for scalability. So it's a very nice article. If you have good amount of time to kind of research and explore, you can read this. Okay, let's go to SPL. So SPL has a lot of programs. So this program library has all these programs: token program, token swap, token lending, etc. I think this particular quest, the token creation one, is going to be based using this library. That's what I'm assuming. So that's why it's asking us to add these dependencies. I'm going to add this, but the issue is this tutorial is a little outdated. So I don't know whether this particular version will work or not. Maybe just gotta give it a shot. Wait, set this cargo automon, not this cargo automon. Yeah. So we have added this. Okay. It's asking us to upgrade to a higher version, but let's see if this works. Let's see if the build, yeah, build has been successful. There is some kind of warning. Yeah, because we are not using this, Rust always gives a warning. If you remember that if we are not using a particular variable, then it gives a warning. And if we prefix it with underscore, it kind of just ignores that. That's why it asks you to prefix it with underscore. That's fine. We know, okay, this is a dummy program. Make sure that the version of the Anchor SPL matches the version of Anchor Lang. Oh, I see. Okay. So that means we should change it. So 10.0.22.1. Okay. It would be much more convenient if you install the same version that we are using in the Quest. After these changes, cargo terminal file would look something like this. This code is missing, but we know what it looks like. Now that we are done adding the dependencies, let's call it inside our program to write down the following use statements at the very top of your lib.rs file. So I'm going to type this out because this is easier for me to learn if I type out stuff. So I'm going to do it, but you can just feel free to copy paste it. Anchor SPL token. Okay, so token is taken from SPL. And then what are the functionalities we need? We need self, we need burn, okay, we need mint2, we need set authority, and we use transfer. Okay. I'm wondering if the new Anchor plugin would make it easier to kind of detect these functionalities that exist. All right, so we use the Anchor SPL library and we take the token library out of that. I'm assuming that it is this one, token program, right, on the Solana blockchain. So token from there, and then we are taking self, burn, mint2, set authority, and transfer. I'm going to make this small. Okay. So, okay, after this, clear all the default code that we are provided with. This would make your coding screen look something like this. Okay, I'm going to remove, let's see, maybe we'll just edit it. Head over to the programs and clear the code there apart from the macro declaration and crates. After the clearing your coding soon, yeah, I don't know what it looks like. But I'm going to probably just remove the initialize function because we don't need it. I'm going to keep the macro, that is the program, and I'm going to keep the module name super in case there's an inheritance stuff. I'm going to remove this because it doesn't exist. Let us simply define our functions that we will be using in our Solana program. Bulk of the program goes in the module under the program macro. We'll just define them under the public mod money and write the logic later. These 4 function definitions would look like this. Okay, let's do it. So we are going to do public function proxy transfer. We have a context. I think this part we have understood very well by now. So we have a proxy transfer amount, and we okay. So for the latest piece of code, it does not use program result. It uses result. And then we have proxy mint and proxy burn. Mint2. Okay, mint2, the amount. Everything has only amount. Okay. Proxy transfer. So, oh, proxy mint2. Okay, then proxy burn. Okay. Okay. So we have all these contexts, and then there is, okay, there is next one is set authority. I wonder why there is a set authority and what it means in the context of creating a cryptocurrency, because the one who's creating is the one who's automatically the authority, right? At least in Solidity. But okay, let's see. So it asks for a context, it asks for a authority type. Okay. It asks for a new authority. It's more like transferring ownership kind of option. Key. Okay. Okay. Authority. Okay. So we have defined. Okay. Let's see now what you're saying. Notice the use of word proxy in each function name. Yeah. Why is it used? That is because we would be doing cross program invocation or CPI for short in this. Okay, so it's like cross contract calls. This means that we would be calling functions, sorry, of other Solana programs from our program. As you might have guessed, oops. Oh, Shweta, are you in this room?
Uh,
Uh, Let me just delete this beginner's room. Yeah, okay. Shweta, you are here? No. Oh, what is this?
No, Shweta was there, but now she's not.
Yeah, because in the breakout rooms, it was showing me that Shweta and Pratik for both is showing some issue. Like they have not joined. I don't know. I think now she's here. Shweta, you're here now?
yeah,
Pratik?
yeah, I'm here. Yeah, Pratik went there. Yeah, he is also here.
Okay, okay. Yeah, it was showing suddenly it showed some pop-up, so I noticed. Twice. Okay.
Okay, okay.
So, okay. So in this we are doing cross-program invocation. That means we'd be calling functions of other programs from our program. I guess that's probably what we'll be doing is we'll be calling this token program functions, I'm assuming. As you might have guessed, we would be calling the functions from the Anchor SPL programs, which is the Anchor implementation of the SPL programs that you can find in the Solana Rust SDK. To look at the structure and explore the Anchor SPL programs more, we have a project. So, program function. Yeah, okay. Reading through that would also help us understand the implementations later on, but this is version 0.17. So I don't know if it's a new one. Okay. Okay, let's now go through here. Pub means public and function. FN is function. This we're already familiar from Rust, implying that there are public functions that can be invoked from our program, i.e. it becomes a client callable program function. The first argument of these functions is always context, which consists of the Solana accounts array and the program ID, which in essence is the required data to call just about any program on Solana. Okay, this you're familiar. The next parameter of these functions is a U64 or an unsigned integer, the amount, which will be using as the amount of tokens in different functions. The program result is the return type of both of these functions, which is now result in the updated Anchor version. which is just an easier method to serve function results. Okay. The context parameter is essentially a list of all the accounts that must be passed. So we can see context such as proxy transfer, proxy mint2, which we will define later. Okay. So our code should look something like this. Yeah, it looks similar. Let's go for the logic. The logic of all of our functions would be very straightforward. We would simply call the functions provided by anchor SPL with the correct parameters. That's it. Okay, that's simple. First, let's update a code as follows. Okay, so in transfer, we are going to use the token and call the transfer with the ctx.accounts.info and the amount. Okay, so for the first one, we are just going to take this token called oh wait, there was something here. Transfer is ctx.accounts.info and the amount. So we are essentially sending the amount and the accounts. Okay, here we say token with mint underscore 2. Okay, and we send the accounts as well as the amount. Then for burn, we say, okay, it's just burn. For set authority, actually we should look at the functions so we know what are the functions instead of copying and leave from here. Okay, so this token program is what we are actually calling, right? How do we call this? How do we see the functions in this program? Set up, we have SQL token. Okay, let's try to find this GitHub. Okay, we have this. We have okay. But I don't know what version this is. That's still okay. I think we just go to token. This is the one we are using. Then maybe we do program. Source entry point. Okay, let's do limp and see. Amount to UI. Okay, these are native mint. I don't know if this is the right folder even. Program 2022. Full documentation is available at sql.com. So I'm token. Oh, is it the same? Sorry. Source is available on GitHub. It's the same. That means it's either program or program 2022. Entry point extension, instructions, generate token account, processor state is initialized. Okay, this seems all about accounts. Instruction.rs. Check program account, token instructions, initialize mint, initialize account, initialize multi-sig. There is a transfer. Things like approve, revoke, set authority. You can see that. Mint 2. But these are all the instructions. Okay. The entry point. Process instruction. So process. Error.print. Instruction lib. We went to the lib. program account. Yeah, this I don't know where is the mint and stuff. Process initial mint. This is initialize mint. Something seems to be happening here. Okay. There is also this great core anchor. Yeah, okay. Fine. I think we should research and come back on this. Official docs. Yeah, the functions that we called here, head over the official docs for the anchor SPL create. Okay. Yeah, it's also not that. All right, so we have called all the token related functions except the authority. So token set authority, CTX accounts info authority type dot into. Okay, I don't know if that's into or info, but okay. Dot into, maybe it's info. New underscore authority. Okay. Okay, let's learn to serialize and deserialize. You might already be familiar with the concept of enumerate or enum. Yeah, that's language agnostic. However, you can think of enums. Okay, we are already familiar. What is serialization and deserialization? Anchor does all the heavy lifting. We just need to know what these terms mean. Serialize is to put together some data in a standard format, and conversely, deserialize means to break down a monolith into a standard format of many pieces of data. In terms of anchor programming, account serialized macro is used when a data structure can be serialized and stored into account storage. So, okay, that means account deserialize is used when a data structure can be deserialized from binary format. This macro deserializes the instance from a given slice of bytes and updates the buffer to point at the remaining bytes. Let's see the above concepts in action. Okay. So if we have an authority type, we are going to say mint tokens freeze account, account owner, close account. Okay, we are creating an enum, and this account serialize and deserialize are used to okay, serialize this and store it into account storage, and then deserialize it from the binary format. Okay, so I think it's more like each action will have a type of authority associated with it. So some authority can mint, some can freeze, some are account owner, and some can close the account. I guess that's what it is. Since literally everything is in the form of account, the derived macro is used to convert this enum in the form of an account. Mint tokens would represent the authority to mint new tokens. Yeah, freeze to freeze accounts. Account owner being the owners of a token account, and close account representing the authority to close a token account. After this, your screen would look something like this. Yes. Small note about accounts. An account is, yeah, I think we have done this before, but yeah, accounts are where everything in Solana is being stored. It's a way for the contract to process data between the calls. So whatever information we have, like state variables, everything is stored in accounts. Okay, defining our first account struct, that is proxy transfer. Every relevant information along with the correct constraints can be passed to our proxy transfer. What and all is required in proxy transfer? Proxy transfer, ideally, transfer would require that do they have the authority to transfer, and do they own that much balance, and what is the amount? So here we see that there is an authority, there is from we are transferring to we are transferring, and token program. I guess this means which token itself they are transferring. Okay, I'm just gonna copy this just in the interest of time. Okay, so the proxy transfer account has a signer who will be the authority, who is the from account, who's the to account for the transfer, and the token program. Okay, all of these are account infos. So then we need, okay, uh, oh sorry, we're not here. Everything on Solana is an account, so we convert the proxy transfer struct into an account using the derive account macro. Okay, this derive account macro. In the code above, the account signer macro is used to enforce a constraint that the authority is the one who signs the transaction, and the mutable macro is used to mark an account as mutable. We want to persist changes in those accounts, right? Because if there is from and to transfer, then the balance will be reduced and balance will be added. I think we did this in another session as well. Okay. Now coming on to the accounts themselves, these are a from account from which the transfer will take place and a to account to which the tokens will go to. Then the authority is the one who should be able to execute these programs, and the token program is identify which function to call from the original crate. Okay. After this, your code screen should look something like this. Yes, it does. Small note about access control macros. The accounts macro implements the account state. Okay, this is the hash derived macro. Transforms the struct from the untrusted and account info slice given to a Solana program into a validated struct of deserialized account types, that is hash account. Oh, and that's it. I think here there should be a full stop. Hash account, it is an attribute, the smaller account and the bigger account. Okay, accounts is a macro that implements the account state. The smaller hash account, this macro, is an attribute macro implementing account serialize and account deserialize. Account wrapper type for a deserialized account implementing accounts deserialize. Okay, using this type within an account's struct ensures the account is owned by the address defined by the declare ID where the inner account was defined. With the above, we can define preconditions for our instructions for any instruction handler expecting a certain set of accounts, allowing us to more easily reason about the security of our program. Okay, yeah. I think this is fairly heavy. Has anybody worked a lot on like Solana programs? I know we have some experts like Pratik and all. So Pratik, can you simplify this for us? Is Pratik on the call? No, he has left. Okay. We will try to invite somebody who can talk a little bit more about how this kind of functions. I understand a little bit. I'm not very like 100% clear. Is there anybody else who wants to take a stab at it? Shweta, do you want to take a stab at this accounts macro? All right, guys, then I shall not stop here for now. Sorry, somebody unmuted. Okay, all right. Yeah. Okay, so now we have to, similarly, we have to define proxy mint to, proxy burn, and proxy set authority with the desired information. Once you had given it your best shot, compare your structs with what we have here. Okay, proxy mint to. Oh, they want us to open up the Anchor SQL crate in Anchor's GitHub. Just a moment. Okay, Anchor SPL source. It's just like literally has nothing. I don't know what they want us to do here. Token, okay. So they are saying open this up. Mint 2 is here. Okay. So if we do a mint, it requires this is the program ID, mint key, 2 key, accounts authority key, and amount. Okay, so let's try to take a stab at it. I will do this. And then proxy mint 2. So what and all they want? They want this one will come from SPL token ID. I guess it will come from somewhere. Mint key. So that means it will be okay. That will be an account. I don't know what this mint key is, but seems like some kind of account. Okay, so I'll keep it account as an account. Then 2 key. So who is the 2? Wait, why don't we see transfer and then try to just emulate that? Transfer has an ID, from key, 2 key, authority, then an array and amount. So I'm assuming this array of accounts. So here they have 2 key and a token program. I think token program maybe is this one. Interesting. So from to authority. Okay. So for mint, there is mint to authority. Okay. So I'll just change the from to mint. I will keep the authority as is, which will be the signer, and the token program will keep it as is. Okay. And then let's try the other ones as well. Maybe burn, proxy burn. Okay, what are they using here for burn? Burn has the ID, 2 key, mint key, authority. Okay, so this might be the ID. There is a 2 key and a mint key, and there's authority. Okay, same, but the order is different. Then approve, initialize account, close account, set authority. So this one, set authority, has the ID ctx accounts dot account or mint key. I'm not sure what this is. There is okay. I'll try this one. Sorry, I wrote it as proxy. Proxy set. Ask for an authority type and new authority. So authority type is something that it's going to ask us. There is no. Okay, so new authority we have authority type, then current authority key. Okay, so signer will be the current authority. Then there is account or mint key, which I don't know. Maybe account mint key. There is a new authority. What is its name? New authority type. Authority type is some kind of account, I guess. And then there is new authority. I feel like this should be some kind of like public key or something. And then current authority. authority, maybe some kind of account info. I don't know. Okay, yeah, if you guys also want to take a stab at it, here is the okay. Mint to authority, set authority, current authority, account or mint, right? Account or mint. Yeah, okay, account or mint, that's what I'm doing. And then current authority. Yeah, I think current authority we have already given as a signer. Current authority, account or mint key, authority type. I think authority type is just like taking as a parameter here, so we probably don't need it in the accounts, right? And then new authority. So new authority is also being sent here, but I don't know if this is like required. So that was my experiment. But let's see. Okay, proxy mint 2 has a authority mint and a 2 and this token program. Okay. Then structure is pretty similar. The difference is a mint account, that is essentially the account of your token, and we could want that to be mutable since you can change supply and so on. Let's tackle the burn next. So here we have the authority, the mint, and 2. Same, right? Structures again also requires a mint account so that the function could know which token account has to be disabled. Okay, so it will disable the mint account with okay, so is this the same thing? Burn, I did the 2 and the mint account, just order is changed, but this is the same. Then let's tackle the final account, the proxy set authority. Slightly different than the rest of the structs. Yeah, pub current authority is the account signer. Yes, it's correct. Then pub account or mint. Yeah, this one we got from there. Then new authority is not there. Okay, all right, so I'll delete this. It's probably because it's going in as the argument here. Okay. Okay. These accounts here are used to determine who the current authority is and whether that authority is the one who has signed this transaction or not, and whether the new authority is going to be another account or a mint. Then there's the token program again to identify the correct program call. This part, I'm still not sure what is account or mint. They're saying whether the new authority is of the token account, is it going to be another account or a mint? I don't know what a mint is. How can a mint be an authority? I don't know. Okay, let's mark these questions and ask someone later. After defining these accounts, okay. Yeah, but now we have one main thing. This is account info. This itself we have not defined. Okay. Say hi to cross program invocations. We spoke about cross program invocations briefly. I think we did it in some session in the beginning. Okay, simply understand that CPIs are used to invoke instructions on another program. To do so, Anchor is pretty straightforward. All we need to is create a CPI context object with the target instructions, accounts, and programs. To perform CPI, just use the CPI model. Accounts used for CPI are not specifically denoted as such with the CPI account label since version 0.15. Accounts used for CPI are not fundamentally different from program or signer accounts, except for their role and ownership in specific context in which they are used. So now with the above points in mind, let's create implementation blocks IMPL which we will use to create the CPI context. I think we should do a little more studying about this CPI. There was CPI on the Anchor book as well, right? Anchor Lang. This one. Accounts. Context as a system program. Declare ID emit require. Instruction accounts. Anchor Lang. Yeah. Oh, okay. Yeah, I think we should do some CPI program first before doing this, maybe to see how this CPI context is being defined, etc. Put this up as well. Part of our okay. So for CPI, I think the rest of this is like just doing the CPI and setting the context and stuff. So we are anyways halfway through, I mean, almost through to our end. So should we do this in the next session? And maybe we do like little bit of CPI before and come. So we have like a better understanding. What do you guys think? Because I think it will take a while to do this. Like at least another 40 minutes or so.
Yes, that will be great.
Okay then. So let's